So, to continue the last lecture, we spoke about rush and item response theory modeling. I mean, the descriptive one, like the two parameter and the three parameter modeling. Here we will just a little speak about what's the benefit of having these modeling and what's the benefit of having a ruler, a common ruler for item difficulty. Or even if we do that modeling through two parameter logistic and three parameter logistic and we do equating, although it's more difficult and precarious and sensitive to diff and drift, but still can be also done with the two parameter and three parameter logistics. Although it's more, the equating is more done with the rush since it's easier. But still, either way, whether it's rush or two parameter or three parameter logistic, what's the benefit of equating these item difficulties and getting a bank, an item bank, in which all these question difficulties stand on a bar, on our ruler. This is very important and proved to be useful in designing new kinds of tests. Uh, these are the main ones here. One is called linear on the fly testing, and the other one is called computer adaptive testing, CAT. Now, as you see here on the right side, there are more than one test form. During the test, at the time of the testing, the test is produced, and the tests actually, not only one test, each student will receive a different set of questions. But all of these sets of questions are equivalent because they follow the same blueprint and they have the same constraints. They say that, on all over the tests. So they are equivalent. And it's called linear because each student will see, I mean, he will solve the question linearly, one after the other. There is a complete set, a fixed length, like 60 item or 80 item, and all of them have the same fixed length set of questions. So it's linear per student, and because the student will solve it one after the other, there is no branching. There is no, I mean, so you solve question one, then you go to question two. There are no two ways after question one. It's only one way. And it's called on the fly because all of these different tests, each one curtailed to a student, all is will be done immediately at the beginning of the exam. So it's on the fly. It's not done before the exam and then stored and then they give it to them on the exam. No, at the morning of the exam, at the beginning, at the very first moment of the exam, they are formed. So each student sits near a computer, and he will see the whole set of questions in front of him made once he entered the exam. That's why it's called on the fly, linear on the fly testing. And this will, of course, minimize like cheating or copying because each student will have a different set of questions. But all these sets of questions are equivalent. How did we know they are equivalent? Because we put them on a common ruler in our item bank because of item response theory. Without item response theory, this could have never been achieved. So, this is the importance of equating. Such exams can be done. Also, on the other hand, the CAT exams, which are the computerized adaptive testing. In this kind of exam, also each student is sitting in front of the computer, and a question will come to him at let's say zero point 0.5 difficulty, middle difficulty, average difficulty, and several questions will come to him, and also follow blueprints. I mean, it's constrained within a certain blueprint, like for such topic, constrained by topics. I mean, and the blueprint is constrained. So, like 7 question on such topic. But the most important thing is that the next question in that topic will be given to the student depending on how he achieved on the first one. So, if he achieved well, the second will be more difficult, and if we achieve well on it, it will go to a more difficult level till it reach to a level where it will be like 50-50 chance of solving the question, and that will be it's here where it will stop, because it will know exactly what is its ability. I mean, not only 50-50, till its ability will never change more. I mean, till it's stabilized. The more you go, you will see you will see that the ability will stay at that level. It won't increase. Okay. So this kind of questions, the cat is supposed to be more reliable than other kinds of tests, and also they are thought to be more economic, because one can know the ability of the student on these various objects. I mean, subjects of the exam at earlier time. I mean, than what's usual happen in linear testing. Of course, this is adaptive; it's not linear, because there are many possible pathways that happens from after you solve a question. The pathway that the student will go will be determined by the question. So here, for example, this is a student, this is a question, and depends on how he solve it, it will go to another question. And at the background, what he doesn't do, that there is a shadow testing. Once he solve a question, like here in CVS and Neuro and all of these, there's like a big exam at the background, you know, and every time it see the test and how it's performing, it will add the best next question appropriate to his level, and also constrained by the blueprint. So this is how it goes. There is like a shadow test in the background. Of course, he doesn't know about it, the student, but that what determines what questions will come to him. So this is the computer adaptive testing, the CATS, which is a very nice kind of test. And so we continue here. Um, Regarding item response theory, there are packages that can go through the item response theory. And the most important of these packages is the R packages. These are free packages available on the internet. So we have the R and the R Studio, and in the R Studio, you can download these basic packages, the most important ones. So from R, you go here through this. I mean, here you download and install R first. You open this link, that this is it, and you see this R, and this has a lot of packages. So you download that. For example, here you download R for Windows, and you go through the steps, and that's how it goes. So this is one of the ways how you do it. Also here, after you finish downloading R, you can go and download and install the R Studio. R Studio, you download it from this. You see here R Studio desktop, and it has the packages. I mean, in it. But first, you need to download the R Studio. It says first install R, then install R Studio. So you download it from here, from this. And after you download the R Studio from pause it here, you will return back and download the basic packages inside the R Studio. So back here, I see here the basic packages. You see them. Let's take that out. And these are the basic packages. You go to the R Studio, you install, you write this, install R packages, which is multidimensional atom response theory. TAM, I think, is testing analysis module. ERM is extended rush module. Psyche, this is very good for factor analysis. And there is ITM and the others. So uh, you install these basic packages through the R Studio, and then you can go and uh, upload your table, which is the zeros and ones matrix, which is the student item response matrix. Since we are dealing with MCQs most of the time, so it is the zero and one matrix, I call it. So these responses, the zero one responses of the students, all the students on all the items, you upload them to the R, and here it will go stepwise through everything. It will do the rush fitting and the difficulties and all of these parameters, and we'll check whether it's rush fit or not. If it needs more than dimension, if it's two parameter better than rush or rush is better than it, and it goes throughout all of these things. You can do it together. You can work through it with an AI like Chat GPT, like 5.2 thinking, and it will help you by going through it. It's really a very enjoying experience. Of course, R is the basic package that Jamovie depends upon. The Jamovie is a very friendly package. I mean that one can go through it. Jamovie is one of the best, and it has a dichotomous Rash model and polytomous also, and various kinds of Rash model. But if you want to go to the two parameter logistic, three parameter logistics, you can dive deeper with these packages through the R, and that's it.